space. The final front... Wait a minute. I can't see a thing. Where's the sun? I guess I'll have to turn up the brightness. Ha ha! There it is. But it's still kind of dark, even though we are extremely far away, more than 3 billion miles. So it's no surprise that only a little bit of sunlight can reach us here. Strange thing is, we're in the middle of the Kuiper Belt, so there should be lots of asteroids around. Just a second. I'll crank up the brightness even more. Ah, there they are, the asteroids at the edge of our solar system. And, oh wait, one of them's coming right at us. Whoa, that was close. It is really impressive to look at, though. Unfortunately, all of these are just lifeless chunks of rock and ice. So let's fly closer to the sun and see what else we can find. Our first stop is Neptune, a gas giant. This type of planet is mainly made up of clouds and liquid. There's no real surface we could land on. Instead, we could visit Triton, Neptune's biggest moon. Its surface is just an icy desert, though. At the moment, it's minus 237 degrees down there. So let's fly on. This is Uranus. It's very similar to Neptune, but even colder, so again, not a very nice place for a visit. Next up is Saturn. It looks impressive thanks to its ring system. Once we get closer, we can see that those rings are made up of little chunks of rock and ice. Saturn itself is also a gas giant, so we can't land there either. And with Jupiter, it's the same. It's the biggest planet in our solar system, and it's got a lot of moons, some of which are really huge. For example, the giant Ganymede, which is bigger than some of our planets. Apart from that, it's just a big plain rock, so it's not really very exciting either. Now we've arrived at Venus. Seen from a distance, it also looks like a gas giant due to its thick cloud-filled atmosphere. But below those clouds, we can see a rocky surface full of volcanoes. It's extremely hot down here, over 400 degrees Celsius. The high air pressure and the acid rain aren't too welcoming either. Now on Mars, things look a bit better. Here we could at least walk around in spacesuits and take in the fascinating desert landscapes. At the North Pole, there's even water ice. The atmosphere, on the other hand, is pretty thin and allows a lot of radiation to reach the surface, so it's not too healthy either. Mercury is very close to the sun and is constantly cooked at temperatures of over 400 degrees Celsius. It doesn't have an atmosphere, and its surface is riddled with impact craters from crashed asteroids. Hardly a surprise that there's no life here. But there's still the 8th planet of our solar system, Earth. Seen from a distance, it looks very blue. That's because of the amount of water on the surface, and the atmosphere, which makes our skies shine in such a nice blue hue, adds to that as well. Once we get closer, we can see clouds and land masses. Looking down from up here, you wouldn't guess it, but at the surface there are lots of different sights. While our neighboring planets seem rather boring, we have an abundance of landscapes. We have juicy green meadows, rocky coasts, snow-clad mountains, bone-dry deserts, Arctic ice fields, majestic fjords, heavenly beaches, and thriving forests. The numerous animals which inhabit our planet are even more exciting. While the other bodies of our solar system could have some bacteria or microbes at the most, our Earth is home to millions of highly evolved species. Some of them are just tiny, while others can grow to really huge sizes. We have many favorites among the animals. Some charm us with their looks, others sport extraordinary feats or intelligence, and some of them impress us with their raw power. So why is it that our planet has such an abundance of life and variation, while the rest of our solar system seems deserted? To answer that, we'll have a look at the creation of our sun and its planets. Everything began as a cosmic nebula. This is a gigantic cloud of molecules of different types, from minerals to gases, and in here, an enormous explosion was triggered. That was the ignition of our sun, which triggered an incredible chain reaction. Components of the nebula in the vicinity of our baby sun were pulled towards it and began to spin around it. This is what we call a protoplanetary disk. Imagine it to be a cloud of all little particles that will eventually make up all of our planets and moons. This process took millions of years. In zero gravity, small particles have a tendency to cling together, a phenomenon called accretion. It leads to the formation of little chunks of matter which get bigger and bigger. Here they've already reached the size of asteroids, which are whirled about by the sun's gravity. They crash into each other, stick together, and get bigger and heavier. That way their own gravitational force increases until it's strong enough to pull in lighter objects. Now they grow even faster and have the potential to turn into full-blown planets. When these planets collect a lot of gas particles as well, they can develop an atmosphere. After the Earth had formed that way, its stellar neighborhood was still filled with debris from the protoplanetary disk. It was constantly bombarded by asteroids. Back then, the young planet was much closer to the sun, so it was incredibly hot. The surface was made up only of lava, liquid molten rock. The cosmic bombardment went on for millions of years until space around Earth finally cleared, so the planet was able to cool off at last. The lava slowly became a crust of stone. Still, there were frequent volcanic eruptions. They spat water vapor from the inside of the Earth into the air, while meteors of ice supplied the planet with more water. A water circulation was set into motion. Water vaporizes, rises up as clouds, and then cools off again, so the water comes down as rain. The rocky valleys of Earth were partially flooded by that water, so our seas and oceans were created. The land masses changed over and over through the course of millions of years, until finally our planet took the shape we know today. Presently, our oceans cover about 70% of the Earth's surface. All in all, they hold about 300 billion gallons of water. And according to scientists, this water was the birthplace of the greatest miracle of our solar system, life. At first, there were single-celled organisms like microbes or bacteria, which in the course of millennia evolved into larger and more complex beings. At some point, the first fish swam through these waters, and today we have over 200,000 different species in our seas. A striking example for this diversity are coral reefs, where we're going to do some diving now. These colorful formations were created by a special type of cnidaria, the stony corals. They emit calcium carbonate, which in time piles up to shape these huge formations we see here. Actually, these stony corals are among the most proficient builders on Earth. Together, all the coral reefs cover an area about as big as the entire United Kingdom. The colorful appearance of the coral reef stems from the stony coral's symbiosis, a helping partnership with certain types of algae. By working together, they create a blooming habitat for fish and other sea dwellers, even in areas which wouldn't offer a lot of nutrition otherwise. In this fascinating biotope, a lot of species live in a symbiosis. A great example are anemone fish, like these clownfish. They can't swim very well, so they hide from predators inside the anemone. In return, they drive off filefish, which would eat the anemones. Interestingly enough, all clownfish are males when they're born. They live in groups of several males and one female. The female is always the biggest and strongest. In case the female dies, within a week the biggest and strongest male fish turns into a female. A great example of the diversity of life on our planet. The jagged surface of the coral reef offers a lot of protection in the form of cracks and caves. Moray eels make the best use of that. They're sea predators that look a little like snakes. During daytime, they only stick their heads out and go hunting at night, after which they always return home. For the smaller reef dwellers, the moray eels are a serious threat. But there are way bigger predators in these waters. This shape in the back there could even give human divers a scare. It's a shark. This seal turns around on the spot as well, not wanting to get in the way of this mighty predator. Swarms of fish, like this one, try to protect themselves from the shark by swimming in a formation and performing evasive maneuvers. But this hungry shark doesn't give up so easily. Once the shark has made a catch, other parties come calling as well. For example, these remora, sometimes called suckerfish. They have a kind of suction cup on their head and attach themselves to large predators. They enjoy their protection as well as small pieces of prey. In return, they pick off all parasites from their host's body. Sharks are a living example of what ocean life looked like hundreds of thousands of years ago, because they haven't changed much since then. And they don't have to change either, as they are the perfect predators of their habitat. Large sharks have no natural enemies that could pose a threat, except for other sharks, of course. This specimen here obviously has had his share of fights. A chunk of flesh was torn out from his lower jaw. This fellow, on the other hand, has lots of heavy cuts and scars on his head. However, we can also find much smaller types of sharks in these coral reefs, like this white-tip reef shark. It's only about 4 feet long. This is a nurse shark. It hunts at night by pressing its mouth against cracks and crevices, sucking out dormant fishes. Here we have a mako shark, which can grow to be 13 feet long and weigh 1,000 pounds. Because of its pointy head, it's able to swim very fast. Some subspecies of the hammerhead shark can grow to lengths of 20 feet. Their very wide head, which makes them resemble a hammer, helps them to maneuver and detect their prey. Sharks have a very good sense of smell and use electrical impulses and magnetic fields for navigation. That way they have no trouble in muddy waters like these. For example, they could detect 1 drop of tuna extract dissolved in 100,000 gallons of water. Their habit of swimming against the tide allows them to catch a scent from an even greater distance. That way they make good use of the change between ebb and flow, which are created by the moon's gravity moving our oceans. And this isn't the only effect the moon has on life down here. But where did the moon come from in the first place? In an early phase of its development, when Earth was being bombarded by debris, a huge piece of rock approached, half a planet in itself. The impact created a huge cloud of debris. Due to the Earth's rotation speed, which was much faster in those days, that debris started to circle around the planet, giving it a look somewhat similar to Saturn. In the course of millennia, these chunks shaped up into a mass of rock once again. Both of these heavenly bodies moved farther and farther away from the Sun, which allowed them to cool off and solidify after the cosmic bombardment had ended. Today the moon is gray and may look a bit dusty, for it's completely covered in regolith, the moon version of sand. But even if the sights aren't too exciting up here, the moon has many different effects on Earth's life. Other than sharks, some types of birds and insects use it for navigation. The mating behavior of some fish is connected to the moon, and many people say they can't sleep too well during a full moon. The fact that the moon is mostly responsible for ebb and flow was suspected by scientists over 500 years ago. Following the brilliant minds of Kepler and Galileo, Isaac Newton came up with the most accurate explanation, which is that the moon's gravity moves the water. Since we know more about the weight of our moon and sun, even flash floods can be precisely predicted. They occur when both of their gravitational forces pull in the same direction. Now we'll go on another dive to find out how life emerged from the water and came onto land. An especially graceful animal we can meet in the coral reef is the hawksbill sea turtle. They live in the sea, and their legs are shaped like fins for swimming. But their eggs, which resemble those of birds, are laid on land. And even though these turtles travel a lot, they always return to the beach where they once hatched to lay eggs of their own. Animals that live in the water as well as on land are called amphibians. In the case of the hawksbill sea turtle, their life on land is really restricted to the laying of eggs, though. They're vegetarians and feed on algae and other plants. Interestingly enough, the baby turtles start off eating fish and shellfish, but once they grow older, they change their diet to a vegetarian one. So they change their habits in a matter of years. Other things may have taken millions of years to develop. Fish who used to dig in the mud for food may have developed increasingly strong forefins until they were as sturdy as legs. And that's how sea life was able to come ashore. Here we see Lonesome George, the last known Galapagos tortoise. Being a land turtle, he has no fins, but legs with toes and claws. Lonesome George was over 100 years old. Some of his brethren supposedly even reached 200 years of age. But even much younger turtles are a little on the slow side. Their rigid shell offers them great protection, but it also limits their movement. Still, turtles can see very well and can even distinguish between more colors than humans. Like all vegetarian land animals, they prefer to eat juicy green leaves because those are fresh and carry a lot of nutrients. Even if turtles are a great example for a species that lives in specialized versions on land as well as in the sea, they're not the species that first came to land. By analyzing a great number of fossils, scientists found out that the development from bony fishes to salamanders happened about 400 million years ago. Salamanders and reptiles of our day and age can give us a good idea of what land life might have looked like back then. Next, we're going to have a look at an especially interesting kind of reptile. Chameleons. They look like little dragons and are able to change their color. Their movement seems a bit awkward and clumsy, but in fact, they're masters of balance. They can use their tail to hold on to things, which makes them able to climb trees and even cross from one branch to another. Their unusual style of movement is a means of camouflage, as it resembles the movement of leaves in the wind. Chameleons have also developed very specialized eyes, which are able to look in different directions at once. That gives them almost a full circle of vision. When the animal is looking for prey, its eyes look around individually. Once something edible is found, they both start looking in the same direction, so they can see three-dimensionally. That way they can estimate the exact distance to their prey. Ultimately, their long tongue lashes out. Surprisingly, their tongues can be up to twice as long as their bodies. Chameleons are famous for their ability to change their body color. However, this is not used as a means of camouflage, but rather as a means of communication. They can change colors and patterns within minutes to threaten rivals or court females. Still, there are some types of chameleons that have adapted their appearance so well to their habitat that they're almost invisible. With this specimen here, you'll really have to look twice to spot it. As you can see, chameleons are wildly interesting. But humans are even more fascinated by dinosaurs. These mighty creatures once ruled the earth. Some of them were as big as houses. But they went extinct some 65 million years ago. The reason for that probably was a meteor about 6 miles in size, which crashed near the Gulf of Mexico. The impact seriously messed up the Earth's climate. A huge cloud of dust might have darkened the sun for years, so that a lot of plants died and the dinosaurs couldn't find enough to eat anymore. However, not all the dinosaurs became extinct. Some of them developed a coat of feathers, as the famous petrified Archaeopteryx shows. It's considered to be proof of the dinosaurs' transition into birds. And if we take a look at this ostrich here, it's easy to imagine that two-legged dinosaurs might have moved in a similar fashion. And these birds, which can grow to be 8 feet tall, can also be really dangerous. If they feel threatened, their kicks can kill a human or even a lion. Today, there are countless different types of birds. Among their numbers, parrots are an especially colorful kind. There are many varieties. Here we see a scarlet macaw. It's a very intelligent bird with a distinct social behavior. Macaws live in groups of up to 20 animals, but they split up once they look for a partner. If a couple has found each other, they'll remain together for the rest of their lives. They also pick their own tree as a home, and when they fly out to look for food, they never fly farther than 6 miles and always return in the evening. Their colorful plumage also has its use for communication, which is also true for smaller subspecies like these pygmy parrots. Birds can tell gender, age, and health condition from the appearance of their peers. Like most birds, parrots can also see ultraviolet light, which is invisible to humans. That way, they can recognize even more details in their peers' coat of feathers. For birds which hunt at night, the perception of the ultraviolet range is useful to spot their prey. This doesn't work in total darkness, but the light of the moon is good enough. The moon accomplished one of its greatest miracles right when it crashed into Earth, because this collision tilted our planet's axis. Since then, it rotates at an angle to the sun, and during its journey around the sun every year, the different continents catch a different amount of sunlight, depending on Earth's position. This leads to changing temperatures down here, which in turn creates the 4 seasons. For animals, plants, and humans, the seasons bring great variety. In Europe's winter, for example, everything is covered in snow and ice. But once we get closer to spring and summer, all of this melts away and the landscapes turn into a juicy green. The trees have grown accustomed to that change and shed their leaves once autumn arrives, because they can't get enough water in winter. By shedding their leaves, they save a lot of energy and can survive the cold season that way. Countries situated close to the equator experience the effects of the tilted axis to a much lesser extent. In North Africa, there's no real winter because the sun hits the surface more or less the same all year. But even the little gradients in rotation lead to an interesting phenomenon. We're flying over the Serengeti. The name of this famous African savanna translates to endless plain. Here, the subtle balance between rain and drought forces about 2 million animals on a journey for food and water every year. In a hot climate like this, life revolves around water. A lot of pools and watering holes dry up in the course of a season, while new sources of water appear elsewhere. For that reason, some animals have adopted to living their life by huge rivers. The first species we meet here is even called river horse sometimes, but more often they're referred to as hippopotamus, or hippo for short. This name seems to suit them better, as they don't have a lot of resemblance to horses with their big heads and bellies. Right after the elephants, they're among the heaviest land animals and weigh up to 9,000 pounds. At first glance, they might seem a bit lazy, as they only lie around all day or stand in the water. This is just their way of efficiently dealing with the tremendous heat in Africa. Surprisingly enough, hippos are nocturnal animals who set off in the dark to go grazing. Sometimes they even have to walk for a couple of miles for their food. If you look at them during the daytime, you wouldn't ever guess that hippos can run very fast, up to 30 miles an hour. Their swimming, on the other hand, isn't very proficient. Even if they have adapted to life by the water and can dive up to 30 minutes, they mostly stand or walk in shallow waters. Their clumsy style of swimming is sometimes described as water walking. Hippos aren't the only animals whose life revolves around the water, though. Many other animals, like these gazelles, come to the river to drink. Here, a mighty lion enjoys a sip of water. But he isn't the only predator in the vicinity. On the banks of the river, crocodiles are waiting. Their scaly appearance hints to the fact that they are descendants of dinosaurs, just like birds. And even though they don't have a lot in common with birds visually, their internal structure shows many resemblances, especially in the workings of the circulatory system. And crocodiles also lay eggs. Their lifestyle seems to resemble that of hippos at first glance. They often lie around motionlessly or float lazily in the river. Unlike the peaceful hippos, though, they do eat meat, and their seemingly passive behavior is due to the fact that they're ambush predators. Other animals could mistake a floating crocodile for a tree trunk, making them an easy catch for the reptile. Much different from the hippos, crocodiles can move very fast in water if they have to. They use their powerful tail as a paddle to propel themselves forward. These crocodiles seem to cuddle rather than go look for prey. This is not unusual, though, as they only make one catch per week on average. They're not as voracious as you might think. Also, they're not in a hurry, because they know very well that soon hundreds of thousands of animals have to pass the river right here at this spot. For now, everything is still green at the watering hole. Animals like these zebras have enough food. There's even enough for the elephants, even though these gentle giants literally need tons of food. A grown-up elephant needs to consume up to 300 pounds of food each day, mostly in the shape of grass. That is why they too have to follow the course of the water when green plants become scarce. They don't have many other worries though. As the largest land animals, they don't need to fear any predators. Even this young elephant is already big enough to fend off even the strongest hunters in the savannah. That is why the nearby cats of prey aren't interested in the least. This lion just lies lazily in the sun. Thanks to his strength, he's known as the king of animals and hardly has anything to fear. Relaxedly, he watches his queens, as lions live in small packs, which usually consist of 1 male and 3 females. The females take care of raising lion cubs, whom they hide somewhere for the first couple of weeks, because the little ones are blind when they come into this world. In the 7th week of their life, their mother introduces them to the pack, and from then on, all of the female lions care for them. The other lionesses even give milk to cubs who aren't their own children. Together, they also teach the little ones what it means to be a lion, for example, by introducing them to small prey. They also have to learn to clean themselves up, even though it has to be said that lions are not as cleanly as house cats. They only lick their paws in the back of their nose. The little ones don't have to do anything for the pack yet, so instead they keep a keen eye out for what the elephants are doing. Elephants also live in groups, but with them it's not the males who are the boss. Instead, they're led by an experienced female elephant. Most of the time, it's a cow at the age of 40 to 50 years, which is not able to have any children of her own anymore. Elephants use their signature trunk like an arm. They shove food into their mouths, greet each other, or throw water and mud at themselves in order to cool off a little. Contrary to the Indian elephants, the African ones have huge ears. They wave them around to fan themselves with cool air, another strategy of dealing with the high temperatures of the savannah. The young elephants learn their social behavior from their mothers. They're very peaceful, but once food gets scarce, they can become a tad more aggressive. These grazing antelopes, for example, will be driven off by our youngster's amazing trumpet concerto. The young lions learn to hunt by watching their parents, but also by play fighting amongst themselves. Here we see them mucking about a bit. Once they get older, those games can get dangerously serious, though, as the males fight for the role of the clan leader, using claws and teeth if they have to. At the moment, everything is fun and games here for the animals. But the scorching sun keeps on affecting the landscape. As the planet changes its angle to the sun a little every day, some watering holes dry out, while new opportunities appear elsewhere. That is why the huge herds have to move on. Here, a group of wildebeest are marching onwards. They often travel in the company of zebras and African buffaloes. As a bigger group, they can protect themselves from predators more easily. The animals react to warning calls from other species, and some even stand guard while others sleep. Slowly but steadily, this part of the savannah becomes too dry. These little piglets and their mommy seem to have trouble finding good food. The water holes dry up, and all the remaining green plants have been eaten already. The giraffes have other places to look for food. In the course of evolution, new species have emerged who have adapted to certain ways of living, even physically. That way, the giraffes turned into the tallest land animals on our planet. Their necks alone are 6 feet long, and with those, they can reach green leaves that are too high up even for an elephant's trunk. And it's with good reason they can fill their bellies that way, as a giraffe needs about 70 pounds of food every day. And at that, they don't only chew leaves, but even twigs and entire branches, as they need a lot of calcium for their bones. Giraffes also live in groups, but they don't bond as tightly as elephants do. Still, they work together to fight off predators who've had a hard time sneaking up on them. With their heads up high and their huge eyes, they can keep an excellent overview of their surroundings. And if a hunter should manage to get in close anyway, their kicks can do a lot of damage. That's why these cheetahs aren't even trying anything. You can tell from their slim frames that they're experts in high-speed hunting. And really, the cheetah is the fastest animal on land. When sprinting, it can reach top speeds of up to 60 miles per hour. The drawback is that it's kind of limited in the prey it can handle. This injured buffalo, for instance, would be the perfect prey for lions. It's dragging a leg and can't keep up with its herd anymore, so it's basically defenseless. But a cheetah has a much smaller jaw than a lion, as well as smaller teeth. So it has to stick to smaller prey like gazelles or impalas. But none of these can be seen around here, so this cheetah mom and her kid have no choice but to keep their eyes open. In the scorching noontime heat, they aren't going to move very far either. That's way too exhausting. For the young ones, the heat is especially unforgiving, so they have to make use of any little patches of shade they can find in the savannah. This white rhinoceros is even less of a food source for the predatory cats. Its most striking feature are its 2 horns, which are dangerous weapons in a fight. However, these animals are much less aggressive than their reputation suggests. The white rhino feeds on grass, and these dry straws here aren't enough to fill its belly. Opposed to these zebras, however, rhinos don't really like to travel and stay in their home territory most of the time. But the giant herds of hoofed animals have no choice but to follow the course of the water. Normally, zebras live in much smaller groups. Usually that means 1 stallion and 6 to 7 mares with their foals. The foals are able to stand right after they're born and sport the typical zebra pattern, which clearly sets them apart from horses, with whom they share many similarities. The pattern's purpose is to confuse predators who have difficulties telling multiple zebras apart in a group. The patterns also keep away horseflies and most probably have a cooling effect as well. Zebras have very good eyes, and with their large movable ears, they can hear even better than horses. If they spot a predator, they give wailing calls as a warning. These little gazelles enjoy the protection of the zebras, as they would be easy prey for the nearby cheetahs on their own. For now, the big cats don't dare to attack, as zebras are known for being tough opponents who bite or kick. Still, once the cheetahs get too hungry, there's a chance they will attack out of sheer desperation. Faced with starvation, all species of big cats are known to attack dangerous prey or even join forces with other hunters like hyenas. And the nearby hyenas are starved too. They eat carrion, so they're normally satisfied with other predators' leftovers. But around here, not a single bit of food can be found anywhere. Still, the hyenas are in luck, as there is a commotion with the large herd. The lions are attacking. As ever so often, the females are driving the heavy buffaloes into a trap, as the strongest and biggest male lies in wait for them, ready to attack. For a moment, quiet falls over the Serengeti. The lions have killed the buffalo, while the rest of the herd have made their escape. But some other animals, like these vultures, have been following the lions' actions. They know they should keep their distance for now, as lions have a strict hierarchy. First, the male lion may eat, Next up are the females, followed by the young ones. But then, the time has come for the vultures. They take to the skies and fly over to the carcass, where the hyenas have also arrived in the meantime. Now these carrion eaters fight over what the lions have left, and we can see how aggressively the hyenas are driving off the birds. Hyenas also follow a strict hierarchy among their packs. With them, the females are in command, and they rise through the ranks the longer they've been with the group. Interestingly enough, mothers help their daughters to reach a good position in the pack. Most of the hyenas are satisfied now, and to add to the carnage, marabous have appeared in the meantime. These bald-headed birds are also carrion eaters, but they're even bigger and more powerful than vultures. The last hyena backs away from these odds and retreats reluctantly. The great herd continues its trek the next morning, ever following the best spots to graze. The elephants are also calling to assemble. The grass has dried up so much, it's just not tasty anymore. Tooting loudly, they find each other. Some of their subsonic calls can be heard for miles by their peers. One after the other they arrive, and once everyone is there, they walk in single file, putting the young ones in between them so they won't get lost or attacked. The herd of wildebeest marches on through the scorching heat of noon. Between them and their destination still lies a big and dangerous obstacle. They have to cross the river known as Grumeti. There are strong currents here which may drive off the animals, none of which can swim well. Additionally, there is threat of crocodiles, who know from their past experience where the best hunting grounds are. That is why the animals pile up by the banks of the river, but there's no other way. So they throw themselves into the water and try their best. Even though this looks like plain chaos, scientists have proven a swarm intelligence with the wildebeest. That means they look for feasible spots to cross as a unit, which in effect helps the entire herd, even if individuals aren't put at risk. Ultimately, this means that not all of them are going to make it. Eating and being eaten is part of nature's cycle, but once again, most of the herd has made it to the other side unscathed. This yearly journey is arduous for the animals, but it's a good example of how the inhabitants of this earth adapt in order to survive. And the mass migration of about 2 million animals is a spectacle that can be considered another wonder of this world. All the commotion in the Serengeti is silently witnessed by Mount Kilimanjaro, the biggest mountain mass of Africa. Its highest peak is almost 20,000 feet high, surpassing all mountains of Europe. It's uncanny how this giant stands out against an almost endless plain. It's pretty easy to explain, though, because this mountain massif was created by volcanism. Volcanoes have always intrigued mankind for their raw, destructive power. At the same time, they have an incredible potential to create, which is underlined by the existence of Kilimanjaro. Its 3 summits were created some 2 to 3 million years ago. The last eruption supposedly happened about 200 years ago. But even today, there's activity below the surface. On average, there's 1 volcanic eruption per week on Earth, most of which aren't dangerous, fortunately. Improved techniques of measuring and predicting this activity can save a lot of lives today. Still, some volcanoes remain incomputable and volatile. Their incredible power can be explained by taking a look below Earth's surface. The Earth's crust, on which all life takes place, is only about 20 to 30 miles thick. Its outer core, starting from a depth of about 2,000 miles, is completely liquid due to its high temperature. It's about 4,000 degrees in there. Another 1,000 miles lower, we get to the solid inner core. Here the temperature goes up to 6,000 degrees, almost as hot as the surface of the sun. This heat creates an incredible pressure, and the Earth's mantle, which lies between the outer core and the crust, is interspersed with liquid stone. This is forced upwards and creates chambers of magma in some places. Once these are full to bursting, the magma is pushed out and erupts in the form of lava. This lava is nothing but liquid molten rock, which solidifies once it cools off. The combination of bulging magma chambers and the solidified lava over time shapes giants like Kilimanjaro. The liquid rock of the outer Earth's core is also responsible for an entirely different phenomenon, which is essential to many of Earth's wonders. Geodynamical effects inside the core create the magnetic field that surrounds our entire planet. It acts like a force field which keeps dangerous radiation from the sun away from us. The sun's energy-rich light is very important for life down here, but it also emits unhealthy radioactivity, which is diverted by the magnetic field and our atmosphere. Also, there are huge plasma eruptions, which would damage our electrical power grid if they reached us. Even though you cannot directly see a magnetic field, northern countries are familiar with auroras, also known as sheet lightning. This phenomenon occurs when charged particles from the solar winds enter the atmosphere. The results are magnificent, colorful streaks of light in the sky. Here we witness some auroras over northern Finland. Another wonder of the internal composition our world has created are Earth's mighty mountain ranges. Their sheer mass dwarfs the Kilimanjaro by far, as volcanism isn't the only way huge mountains can be created. The solid crust of our planet is made up of 17 plates, which simply put, float on top of the Earth's mantle. They only move a couple of inches per year, but still in the course of millions of years, that is how our mountain ranges were created. When two tectonic plates collide, one of them pushes itself onto the other, and the surface folds in the process. Gigantic masses of earth and stone pile up on top of each other. Just like the Himalayas in Asia, where the highest mountains of our planet are located, the Alps are also a range of fold mountains. This mighty mountain range stretches out for over 600 miles and runs through 8 countries. There are more than 100 summits here that sport a height of over 10,000 feet. Of course, this offers a great challenge for mountaineers. In their quest to beat the powers of nature, they've put summit crosses on many of these peaks. Still, visitors like those are rare up here. In these highest of heights, there's hardly a chance for life to prevail. These mountain goats can't find anything to eat either, and have to climb down rather sooner than later. A certain species can still watch these summit crosses from above, namely the cranes. These migratory birds pass the Alps on their yearly journey south, even if they mostly choose a route of lower altitude. The demoiselle cranes of Asia, however, have to cross the Himalayas each year to get to their winter quarters in India. They can fly 25,000 feet high, but still the journey over the highest mountains of the earth is dangerous to them. When the winds are unfavorable, they can die from exhaustion or they're hunted by gold eagles. In completing their journey against all odds year after year, they're the bravest migratory birds of them all. But mankind didn't give up either, and humans started to settle in the mountains. As far back as 5,000 years ago, they went hunting in the Austrian Alps. Today, there are lots of villages and even smaller settlements, like this farm in Tyrol, where we see the traditional seasonal droving of cows to the high mountain pastures in summer. Conquering the mountains also brought new scientific insights to humanity. 1,500 years ago, Leonardo da Vinci examined fossilized marine animals that were found high in the Alps, solidly fused into stone. Modern research was able to prove his theory that these gigantic mountains once were the bottom of an ocean. It turns out that the limestone the Alps are made of consists of millions of sea dwellers like shells and snails, just like a coral reef. According to these findings, there used to be a sea here millions of years ago. But when the African tectonic plate collided with the European plate, that sea floor was pushed up thousands of feet. The seam where the two plates met can still be seen in the mountains today. It's called a fault line, and it runs all the way through the Alpine mountains. But even this could change in a matter of 1,000,000 years again. Scientists have found out that the Alps were once over 6,000 feet higher than they are today. Here we can see how this might have happened. When thaw water runs into little cracks in stone, it can break off some of the stone when it freezes again, because ice takes up more space than water. This is how these extremely rugged-looking ridges were created. Another proof of the incredible creative power of our world. However, the millions of tons that are missing according to calculations cannot have all been taken by frost weathering. A much bigger erosive force must have been at work, a powerful force known as glaciers. Glaciers are huge formations of ice which are created by snow falling onto snow over and over again. By means of the rising weight, the lower layers of snow are compressed and turned to ice. Factors like gravity set this incredibly heavy ice mass into motion, so the whole glacier travels several feet per year. It breaks off protruding pieces of rock and drags them along, so the glacier works like a gigantic sandpaper. The results are vast canyons that look like rivers or roads when seen from above. Still, one question remains, and this is how could there be glaciers over 10,000 feet high? The answer to this are the ice ages. On several occasions in Earth's history, northern Europe and the Alps were completely covered in snow and ice. This caused the erosion that cut these mighty mountains down by 1/3 of their height. But even today, the Alps are very impressive and offer many breathtaking views. The timberline of the Alps is located at 6,000 feet above sea level. Below it, we can see widespread forests of cold-resistant trees like pine, spruce, and fir. In these forests, there's also animal life, though its diversity cannot compete with the rainforests of South America and southwestern Asia. These forests are so huge that we're able to see them from orbit. Here we're looking down on the Amazon rainforest. This evergreen jungle is spread over 2 million square miles. In a tropical rainforest, the vegetation is typically arranged into layers. At the bottom, we have the forest floor, which is inhabited by insects like these leaf-cutter ants. Then there's the herbaceous layer, where ferns and grass grow. Next, we have the shrub layer, which contains bigger plants. And finally, we get to the tree layer, with its many trunks reaching up to the canopy at a height of about 100 feet. Each and every one of these layers offer different ecological conditions, so a lot of animals have adapted to a certain area. Through this diversification, up to 30 million different species of plants and animals live in our rainforest. Still, not everyone will like the fact that a majority of these animals belong to the ranks of insects, millipedes, and spiders. But we can also find some cuddly animals in South America's jungle. For example, this ocelot, a kind of small cat. In spite of its name, it's still double the size of our house cats. Ocelots are very shy, nocturnal animals who live in solitude, which is why this one retreats to its lair now. Jaguars certainly are a lot bolder. They're the third biggest kind of cat and live in these rainforests. The type here is often referred to as a black panther, when in fact panthers are not really a species of their own. They're regular jaguars, only with a very dark fur. Another type of predator hunting in these parts are the huge snakes. The boa here is not poisonous, so it doesn't pose that much of a threat to humans. Nevertheless, when looking for food, it's absolutely deadly. Even if most snakes can't see very well, their other senses allow them to keep their prey in perfect focus. Their split tongue gives them a directional sense of smell, and large snakes like the boas have facial pits that allow them to detect the slightest changes in temperature, giving them a kind of heat vision, enabling them to detect hidden, warm-blooded prey. This isn't very helpful with this snail, though. It's cold-blooded. Also, the snake couldn't digest its housing anyway, since it swallows its prey as a whole. In this image, a small rodent is hiding. Even though we can hardly see it, the snake can sense its body temperature, so it noiselessly slithers closer. Once the prey has been swallowed, it slowly travels through the snake's digestive tract, which extends almost over the full length of its body. Digestion of larger meals can take up to a couple of days, during which the snake hardly moves. The rainforest is fittingly named for its precipitation. It really rains a lot here. Even in the dry season, which basically is the summer of the rainforest, it rains almost every afternoon or evening. This jaguar is getting pretty wet now, but it seems he doesn't care too much. He knows that this downpour won't take very long and everything will dry off soon, so he just waits it out and uses the heavy rain as a shower, after which he carefully cleans himself. Even if rain can be unpleasant at times, it's nothing less than a blessing. To fully appreciate that, we're going to take a look at the driest places on our planet, the deserts. Almost a third of the Earth's lands are made up of deserts, areas where there's next to no precipitation. This makes these areas a hostile place for any living being. Probably the best-known desert is the Sahara in Africa, which almost takes up as much space as the USA. A fifth of the Sahara is made up of plain sand. But even if it looks like the sand just sits there, it sometimes really gets up and about. Regularly, there are gigantic sandstorms in the Sahara, which can quickly cover areas the size of the UK in dust. These dromedaries literally try not to bite the dust now, but there's hardly a chance to outrun a sandstorm. Luckily, this is not a life-threatening matter to these animals, who are very well adapted to deal with drought. They can conserve water so well that they can go for 2 weeks without having to drink a single drop. The light dust forms clouds which can reach up to 1 mile in height, while the heavier grains of sand are blowing quite close to the ground. That creates an effect like a sandblaster, and any rocks that stand in the way get chiseled off at the base. We can see the results very clearly in these images. Given enough time, even the biggest chunks of rock will eventually collapse and get smaller and smaller until they turn into sand as well. Because that is just what sand is, stone ground into the finest grains. In a way, the wind becomes a sculptor here, and has created many interesting pieces. Even though it's one of the biggest suppliers of sand on our planet, the Sahara is not completely dry. There are also oases, little sanctuaries of water in the middle of the desert. In most cases, this is due to subterranean water coming to the surface. Sometimes, water rains down near the faraway mountains like the Atlas Mountain in northwestern Africa. There it seeps into the ground until it hits a waterproof layer of stone. Then it flows below the surface and re-emerges in depressions, as we can see here. Still, there are also much larger sources of water bordering on the Sahara, like the Red Sea. The contrast between the light sand and the blue sky reflecting in the clear water creates striking views. The Red Sea is a neighbor to the Indian Ocean and indicates the meeting point of 2 tectonic plates, the African and the Arabic plate. Because these two constantly drift apart, the Red Sea gets about 1/2 inch wider each year. Under the surface, we find a diversity of life, including coral reefs. Since seawater is always saltwater by definition, it's not suitable to support plant life on land. For that, fresh water is needed, coming from lakes or rivers. And not too far from the Red Sea, we can find the longest river on Earth, the Nile. It's over 4,000 miles long and runs through 5 African states before it flows into the Mediterranean Sea. It cuts a green aisle through many desert-like areas, especially in the Nile River Delta near Cairo, where irrigation systems are used to allow for abundant plant growth. Here we can clearly see the contrast between those green areas and the historical Egyptian sites. Thousands of years ago, people already made good use of the natural supply of fresh water. A fascinating civilization emerged. Some call it the first superpower in the history of mankind. As early as 5,000 years ago, dam walls built up to 50 feet in height were built here to hold the Nile at bay and control its flow. Many other impressive structures followed. The most monumental ones are pyramids, the resting places of the mighty pharaohs. Even today, they're considered to be world wonders, and it's still unclear how they could be built with the technology of their time. The burial chambers on the inside are very complex, and their secrets have not been fully understood to this day. Another imposing construction is the Sphinx of Giza. This gigantic statue is 63 feet high and displays a lion with the head of a human, probably a pharaoh. Between its paws we find a plate installed by King Thutmose some 1400 years before Christ. He had the Sphinx dug out of the sand after it had partially been buried for hundreds of years. The sun cult of ancient Egypt could explain its orientation. The Sphinx faces east, always watching the sun rise, and it's been doing so for over 4,000 years. Even if today's scientists haven't yet found the key to all the secrets of ancient Egypt, it's known that the marvelous pyramids could not have been created without the Nile, as humans cannot thrive without fresh water. We're now looking at the place where the Nile flows into the Mediterranean Sea. This means the fresh water dissolves into salty waters, which make up 97% of all the water on our planet. This poses the question, where does fresh water come from, after all? The answer is given by Earth's water circulation. Salty seawater is heated by the sun and evaporates, leaving the salt in the ocean. The warm water vapor is carried away by the wind until it cools off in the mountains, where it forms clouds. We can nicely observe this process using time-lapse photography. In these mountains, the clouds come down as precipitation, either as rain or snow depending on the temperature. Sooner or later, the water is collected in rapidly flowing mountain streams, which are very rich with oxygen. Because of the high flowing speed, plants and animals can hardly hold on here. Glaciers also release the water they have collected in the form of snow and ice as meltwater, which runs into mountain lakes or streams. Driven by gravity, this fresh water sometimes travels thousands of miles until it eventually flows back into the sea. Here we see the river mouth of the Rhine, where the most water-rich river of Europe finds its way back into the sea. Sometimes the water also comes across obstacles, like man-made barrier lakes, or it can go into free fall, as in the case of this majestic waterfall. During its continued journey, the water depletes a lot of its oxygen. At the same time, it collects nutrients and often branches off into little brooks where it appears brownish and flows very slowly. But still, it's as life-giving as ever. The incredible power of water and ice can best be observed in the Earth's northern regions. This is why we're making a stop in Øresund, in Norway. As you'll see, erosion hasn't only eaten away at the Alps. This also happened in lower regions. And an imposing example of this are the Norwegian fjords. These mighty valleys were created when glaciers churned through riverbeds and carried away incredible amounts of rock. The original valleys got wider and deeper, and in the process, these typical steep cliffs were created. Depending on their hardness, they eroded even further, which created truly unique landscapes. The coasts of Norway are among the most impressive ones on Earth because they're littered with countless bays and islands. Still, it's the fjords who are the hallmarks of Norway and attract lots of tourists from all over the world. Here we're gliding through the Geiranger Fjord, a UNESCO World Heritage Site. The cliffs we see here are up to 3,000 feet high. This is the Preikestolen, which translates as preacher's pulpit. It was created by frost weathering some 10,000 years ago. The steep cliffside drops for almost 2,000 feet, and the Preikestolen is a favorite destination for hiking trips. The view into the Liesefjord from up here is majestic. The Liesefjord itself is about 25 miles long and runs up to 1,600 feet deep. It's made up of bright, smooth granite rock, which also gave it its name, as Liesefjord simply means the light fjord. Even farther north, we find a group of islands which are part of Norway and are natively known as Svalbard, which means cool coast, another very apt name, as we have an Arctic climate here. We're approaching the last mainland before the North Pole, which is only accessible via shifting plates of pack ice. Many expeditions to this northernmost point of our world started here. There are even polar bears on these islands. These animals are the largest land predators. They can grow up to 11 feet long and weigh up to 1,600 pounds. This is why they can be considered dangerous. All over the islands we find these warning signs. We can find a slightly smaller but hardly less dangerous relative of the polar bears in Canada. This North American country also reaches up to the Arctic Sea and is the second biggest country in the world, if you count the numerous lakes and rivers which take up about 10% of Canada's total expanse. The huge waterways are evidence to Canada's being shaped by glacial movement during the ice ages. The network of streams and rivers is dense. The longest river is the St. Lawrence River, which is just over 2,000 miles long. Near these waters we can meet brown and grizzly bears. Grizzly bears live in many parts of the world, even in Europe. But only in Canada do they reach their full size of up to 1,000 pounds. This is because of their diet. Large bears eat almost everything, including plants, eggs, and even carrion if they have to. But the best nourishment for them is a hearty diet of salmon. Salmon have to endure another remarkable migration in their lives, and they also contribute a great deal to the ecosystem of northernmost America. They're born in fresh water, but spend most of their lives in the ocean. Once it's time for them to breed, they return to the place of their birth with incredible accuracy. And this means a cumbersome and dangerous journey up the river, against the stream, and across serious obstacles like rapids and waterfalls. Salmon can jump up to 10 feet high, but another danger that awaits them at the waterfalls are the bears. They know that in the breeding season these waters are so full of salmon that they just have to pick them out of the water. This not only creates a feast for the bears, apparently driven by instinct, they carry a part of their catch into the forest. They leave up to half of what they can get their paws on there to rot. Through these remains, lots of nutrients reach the soil, which regains a great deal of fertility that way. This allows the lush plant life to grow despite the harsh and cold conditions. You could say bears and salmon do their part to keep Canada's magnificent landscapes alive and well. Besides the salmon, Canada is also the goal of yet another impressive animal migration. If you consider the size of the single individuals, it's even the longest in the world. Here in Mexico, we find ourselves at the other endpoint of that journey, where its participants seek refuge from the cold of the north in winter. But at the moment, none of them seem to be around. Now we've found a specimen. It's a monarch butterfly. And this one won't be alone for long, as we're right in the middle of their winter quarters, where millions of these insects come together in a tiny space each year. A truly fascinating display of nature. In order to get through the winter unharmed, the animals sit very close to one another, sometimes even on top of each other, so they can beat the cold temperatures. Below 10 degrees, they can't fly at all. Their travel route from Canada to Mexico measures over 2,000 miles. In one day, a butterfly can cover about 30 miles. If we were to scale this up to the size of a human, this would equal 370 miles per day. The whole distance would mean going twice around the entire planet. A real wonder. But with all kinds of butterflies, the way to adulthood is the most interesting. The females lay eggs and caterpillars hatch. In the case of the monarch butterfly, These caterpillars sport distinctive yellow-black stripes. This is a warning sign, as they only feed off of milkweed, which contains a poison the caterpillar is immune to. It stores the poison in its body, so if birds or other animals eat it, they'll get sick and remember to avoid this food. The same is true for the adult butterflies, which still carry the poison inside them. Before they become adults, the caterpillars turn into jade-green cocoons first. The butterfly develops on the inside and hatches eventually. Its striking orange-black pattern is another warning that reminds predators of the poison. There's even another butterfly who makes use of this effect. The North American viceroy looks a lot like the monarch, even though it's not poisonous at all. Still, animals avoid eating it for the resemblance. This charade of nature is known as mimicry. And there's another fascinating fact about the monarch's journey. One specimen usually lives for 5 to 6 weeks. On their journey up north, the females lay eggs, and it takes 3 generations until they've reached their goal. The 4th generation, however, makes the whole trip back down to Mexico in one go. So these animals live thrice as long. They don't mate on the way back and have no children, so maybe that saves them energy, which results in their longer life. Altogether, these tiny animals offer several examples of the wonders life is capable of on our planet. A place where we can get to know yet another entirely different variety of life is the island of Madagascar. It lies in the Indian Ocean off the coast of Africa and is a real gem of creation. About 90 to 150 million years ago, Madagascar was separated from Africa and India through the drifting of the continental plates. Today, the island is over 250 miles out at sea, and this has given it the nickname the Eighth Continent. Not only does it lie in the middle of the sea, but through the separation, which lasted for millions of years, many totally unique types of animals and plants have developed here. These rainforests offer a very broad palette of special flora and fauna. Here we can visit steep and craggy mountainscapes, but not far away we find meadows and wetlands. There are also savanna-like valleys of tall growing grass. Drier areas are adorned with huge cacti. Similar to the African mainland, there are palm trees, and also the thick and wide baobabs known as monkey bread trees. Under these golden rays of sun, we can appreciate the full range of Madagascar's charms. The best-known animals on this unique island are lemurs. Their forefathers happened to live on the part of the mainland that separated and moved out to sea. To cope with the extremely diverse environment, over 100 different species of lemurs have developed since then. Among the most popular ones are the katas, with their striking striped tail. Large lemurs like the katas are very social animals. They like to cuddle or play with one another. Only when looking for food do they set out on their own. The treetops are where the majority of lemurs spend most of their lives. Up here, they're protected from predators, and they're excellent climbers, a feature they share with their more distant relatives. Maybe you already guessed it from their appearance, as they resemble a kind of cross between monkeys and dogs, while the length of their snouts varies with race. Scientifically, lemurs belong to the suborder of wet-nosed monkeys, and a lot of their traits remind us of classical apes, like the fact that they have 2 pairs of hands. They like to use those for holding onto branches while plucking food. And when they clean each other's fur, they also do that in a monkey-like fashion. And if they have an itch, they passionately scratch themselves. Their skilled hands aren't only good for fast movement through the trees, they also come in handy with the opposite, finding a relaxed position to, well, just hang out. After all, lemurs really like to stick to their trees, a real shame since they have such a cute way of moving on the ground. Lemurs use their tail for communicating and balancing. Some types of lemurs even store fat in their tail instead of their bellies. Due to their different specializations, different species of lemurs have a vast range of sizes. Some of the smallest barely weigh 2 ounces, while the biggest ones can grow to 20 pounds. Some of the smaller types have adapted to a nocturnal lifestyle in order to be safe from predators. Like cats, they even have a reflective layer behind their retina so they can see better at night. Most of the little ones are born at the end of the dry season, so they can spend their first months of life with the abundant food supply of the rain season. This lemur mommy belongs to the kind Madagascans call babakoto. They're the biggest lemurs and the only ones to sport a stubby tail. Their faithfulness to their lifelong partner, their song-like calls, and their supposed love for the sun have made them a holy animal on the island. Other large species of lemurs also carry their offspring around. The little ones have to hold on tight as their mothers show a lot of acrobatic moves while traversing the forest. The special skills of the different types of lemurs are manifold. Some can shift their sleeping-wake cycle according to season and food supplies. Some have an elongated tongue to be able to drink nectar from flowers. Others have a digestive system specialized to eat certain types of plants. The menu of the lemurs consists of leaves and grass as well as spiders and millipedes. But the most tasty food are juicy fruits, of course. Such a treat can make a little lemur really envious. But even though males and females can hardly be distinguished visually, women have the right to the best food. Still, who knows? Maybe an exception could be made in this case. It's worth a try. Go for it, kiddo. But even though this little guy tries his cutest look, it's just not good enough. Of course, not only lemurs and other animals inhabit Madagascar, man has settled here as well. For the local populace, rice is an important food source, and to grow it, these terraced rice fields have been created. The rice grows underwater here, which yields far better results, even if it is more labor-intensive. However, paddy farmers are mostly poor. The social status on the island is measured by the number of cattle they own. The major livestock here are zebus, humped cattle originating from South Asia. Zebus are more resistant to tropical diseases and better accustomed to high temperatures than Western cattle. To make space for as many of these animals as possible, a large portion of the island's rainforest has already been chopped down. Up to 2/3 of it is gone already. And just like cattle farming, rice terraces create a lot of methane, which drives global warming. This is the downside of human expansion on Earth. Nature has to make way, and more species of animals and plants are lost forever. This is, of course, a global problem. Mankind builds and prospers. A small brick furnace can quickly grow into a huge factory. cities increase in population and size, our need for energy and food is always on the rise. 100 years ago, about 2 billion people lived on Earth. Today, there are 7 billion and counting. To make room for agriculture and grazing lands, forests are cut down, so the habitats of wild animals dwindle. Factories, cars, planes, and cattle keep on producing pollutants, which disturb Earth's delicate balance of climate. We cannot even begin to foresee the changes this will bring. And another problem is industrial pollution. Waste and even poisons are disposed of in the ground and sea, threatening precarious creations like the wonderful coral reefs. Our cities get busier and more crowded day by day. The main goal of most businesses is to make money without thinking of the consequences, or even of ourselves. After all, life in an environmentally unfriendly city isn't healthy for humans either. For poor countries, it's especially difficult to keep an eye on environmental friendliness. This is why successful nations should dedicate themselves to advancing ecological technologies, and some major cities are already taking on that challenge. Vancouver in Canada has set the goal of becoming the world's greenest city by the year 2020. Even today, 90% of the city's energy needs are provided by water power. Also, the city has the lowest carbon dioxide emission per capita of all the Americas. Of course, there are also European cities committed to progress. Nordic capitals like Oslo in Norway have taken the lead. The city has resolved to become carbon dioxide neutral by 2050. Ultimately, we can all do our part in helping nature. Saving only a little bit of energy and producing a little less waste can make a huge difference if we do it all together. Then the entire planet will marvel at its many wonderful inhabitants for a long time to come. After all, if we consider all the unlikely factors that have led to the creation of such a luscious, thriving planet like our Earth, in the middle of dark and cold space, we hardly can call it anything but a wonder. Can all these cosmic coincidences really be a product of chance? Or is there a divine spark behind all this, or another galactic force? This is a question even science cannot answer with certainty. What is way more important is that we appreciate being part of this. Once in a while, we should remind ourselves of how beautiful it really is, our wonderful world. Karamax, I am your father. Energy. Beam me up. May the wonders be with you. Live long and wonderful. to infinity and then some. Up and at them, up and at 'em. Come with me if you want to learn. Roll out. I'll be back. End of line.